Hi everyone. So here I'm going to continue on lesson 28, which is optimization. So here I have a function and I want to, for example, maximum or minimum it. And also when I have several variables, I have relationship between them, and then I can find one of them based on the other. I can substitute. I can make my function based on just one variable, and then I can find the derivative equals 0, and then I can find maximum point or minimum point for the function. So here it's a rectangular fence. So for example, let's say I have a rectangular fence, so which is here. Okay, so here let me see if I can. Yeah, so I have a rectangular fence, which is a rectangle, and the perimeter is 100, so means the surrounding is 100. So if I have x and x here, and if I have y and y here, the perimeter, which is the surrounding, it's 2x plus 2y equal 100. Okay, that's the relationship between two variables that I need. Okay, then what do I want to make maximum and minimum? I want to make the area maximum. So the situation is like that. I give you 100-meter fence, and I tell you you can make a land with that, and the land is yours. And then I tell you, so of course you want to make the area of the land maximum, because you are just able to use 100-meter. You want to just make the biggest possible land that you can with those 100-meter fence, in order to have benefit, because I say that land is yours, so you want to make the biggest one. Okay, so you would say, okay, so I have 100-meter fence, so in just on a piece of paper, I do a rectangular land, and then I say, okay, so I know the fence goes here, so I know the fence goes here and goes here and goes here and goes here, so I can add all of those. And when I add all of those, I have this relationship. I have this here. Okay, and then I say, but I don't want but I want to make maximum is the area. So area, I want to make maximum. So what is area? So area is, so see here, for the perimeter, I can write here. For the perimeter, I do 2x plus 2y equal 100. And for the area, I say a x and y is xy. Okay, so I multiply them, x and y. So the area is a function based on x and y, both of them. So the area is that, and this is the area. So this is the area. The area is this part. So all the part, okay, that you see here. This is the area, and the perimeter is this one. Okay, so this is the situation. So you have 100-meter fence. You want to make a rectangular land. I tell you at the end, I tell you the land is yours, so you want the biggest one possible for the area. Okay, so first you picture the question, then you write the equation that you want to maximum, make it maximum. You see the equation is based on two variables. You cannot do that, so you make another relationship by another piece of information you have from the question, and then you say, okay, good. I can eliminate y. Here I can eliminate y. Okay, so how do I eliminate y? Here, how do I eliminate y? So I go here and I just substitute. See here, I say, okay, so I have 2x. Of course, if I can make this not to move, so 2x plus 2y is 100. So x plus y is 50. So what is y? Y is 50 minus x. And then I can change axy. Instead of xy, I can change ax is x times 50 minus x, which is 50x minus x squared. See, I have a function. I want to make it minimum or maximum. For example, maximum piece of land for area, or minimum the cost, for example, for a factory. And I have a relationship. I see I have two variables, but I have a relationship between them. So I use the relationship to find y, and then I substitute, and then my equation will be this one. Oh, perfect. So I take the derivative, because here I can, here I know. Okay, So I take the derivative here and I see, okay, so a prime x is 50 minus 2x. Then I put a prime x equals 0 and x is 25 meter. Was it meter? Of course. Yes, meter, 25 meter. Okay, so then I find a double prime and I see a double prime is minus 2. A double prime is always negative, so a has minimum at this point. What is y then? Y is, I have to find y as well. Y is 50 minus 25, which is 25 meter. Okay, so the piece of land, so here I solve for y. So here I can go solve for y here. So y is 50 minus 25, which is 25 meter. Okay, so write the conclusion sentence. So look at this. The land that has 100 meter as a perimeter, okay, must be an square. If I want maximum area, it must be this, and this meter. Okay, all sides must be equal. That's a very beautiful question. Okay, so then I can say the conclusion sentence. The land whose perimeter is 100 meter and the area is maximum is an square. All sides are equal and all sides are 25 meter. Okay, so check the second derivative test that we did, done the last page. So done in so I can say done in green. So and then I can make it green there. Okay, so yeah, so here I can go there and just show, yes, this one. Okay, this is second derivative. Look at this. If I want 100 meter fence, you can say, okay, I make 1 meter here, I make 1 meter here, I make 99 meter here, I make 99 meter here. Of course, it doesn't make any sense, but I'm just showing you, okay? What is the area of that? Okay, so 100, sorry, it must be 49. So 49 meter, and that's 49 as well. Okay, so that's 49 meter. So when I add them, it's 50 plus 50 is 100 meter. Okay, but what is the area here? The area is 49 meter squared because I multiply them. Then you would say, no, I want 2 meter, I want 48 meter, I want 2 meter, I want 48 meter. What is the area? 2 times 48, which is 96 meter squared. Of course, it doesn't make any sense because this is not a nice piece of land, okay? So I'm just showing you mathematically. But the answer is not that. The answer is 25 meter, 25 meter, 25 meter, and 25 meter. And what is the area here? The area here is 625 meter squared. And this is the maximum. Look at that, 49, 96. You can continue, but this is the maximum area possible you can get. This is the maximum area possible you can get for a piece of land that has 100 meter as perimeter. Okay, so if I give you a 100 meter fence and I ask you, you can make a land and the land is yours, you want the biggest one possible, and this is the way. Okay, so another example. A biologist wants to make a rectangular cage along the outside of the lab and has enough material for 60 meters of fencing. Only three sides must be fenced. Okay, so here I have the lab, and here is fence, and here is fence, and here is fence. Okay, so fence here, and fence there. I don't need to fence the other side because the other side is a wall. Okay, now what are the dimensions? So here I give you 60 meter instead of 100 meter, and I tell you you can make maximum area, but remember you just do 3 sides, not 4 sides. Okay, so you say I have x, or for example doesn't matter, I can do x, x and y. Okay, right? And then I can say, okay, I know 2x plus y is 60, yes, and I know a, x and y, which is area, is xy, and I want to maximum a. Then I say, okay, I cannot do it with two variables, so I have to remove. So I have to find y here, which is 60 minus 2x, and I have to substitute here, and I need to make ax equal x times 60 minus 2x. Oh, perfect. Now I have just one variable. So ax is 60x minus 2x squared, and a prime x is 60 minus 4x. So a prime x is equal 0, x is 15 meter, right? 15 meter. Am I right? Yeah, 15 meter. And then a double prime x is minus 4, which is always negative. The second derivative is always negative, so for sure this point is maximum. Maximum happens in this point. And then I say, how about y? So y is 60 minus 2 times 15, which is 30 meter. So if I give you 60 meter of fence and I tell you you can make a land beside the lab, and you are not able to, you don't need to use the wall, you don't need to use the fence for the wall, you can do this. Okay, so you can do this 15, let me see, so x is, yes, x is 15, so 15 meter and 15 meter, and can make it double, 15 meter, and this is 30 meter. When you add them, it's 60 meter, you add them all, it's 60 meter. Here is the building, you don't need fence for that, and when you times there, it's 450, it's 450 meter squared for the area. Whatever else I do, maybe I use 60 meter fence to make a land, but the land would be smaller. Okay, so for example, if you say, I make 10 here and I make 10 here, which is 20, and then I use 40 here. Okay, so when I add them, yes, I know when I add them is 10, 10, 40, which is 60, but when I multiply is 400 meters squared. So this is not the answer. Okay, I know I can use several numbers, but I'm doing it mathematically. So you have to make the equation you want, you have to make the function you want to find, you want to maximum, you want to make it maximum. You see your equation is based on two variables, so you can find the relationship between two variables, which is here, and the relationship helps you to remove one of them. And then from here, it's just math. You just have one function based on one variable, which is here. 2x squared is here. And then you find the derivative. Derivative equals 0. You find the answer, 15 meter. You check if the answer makes that function maximum. And you see it is. And then you find y. And then you just can check it. Okay? So, now practice questions. Practice questions, we for the lesson we didn't do them before, but I can do it now. So when you cough, the radius of your trachea decreases, affecting the air of affecting the speed of the air. If r0 is the normal radius, the relationship between the speed and the radius is given here. See that this is a question into just biology, so you can read it, you can, so maybe so in different perspective you can understand. It doesn't matter, you can discuss, doesn't matter, but here we are doing the math part. See, I have the speed function is SR 5 R0 R squared R0 minus 5 R cubed. What is R? The radius. What is R0? Normal radius, which is a constant number. Is is R0 given? Yes, this is R0. So I can say it is 5 times 1.5, which is 7.5. So it is 7.5 R squared minus 5 R cubed. Find the radius for which the speed is maximum, greatest. So I want this guy to be maximum. And I have just one variable, perfect. So I don't need to use another piece of information to remove one of my variables. Okay, so this is a speed, done. From here, I have a function and I want to make it mix maximum. So I find S prime R, which is 15R minus 15R squared. Then I put S prime equals 0. It is 15 R times 1 minus R equals 0. R is 0 or R is 1, so that one is not possible, so R is 1. Then I find the second derivative. Second derivative is 15 minus 30R. Its second derivative at 1 is 15 minus 30, which is negative. So for sure, S is maximum at R equal 1. Sorry, R equal 1. So 1, of course, it's 1 centimeter. 1 centimeter. Okay? So I can explain. The speed S of the air, okay, of the trachea during a cough is maximum at 1 centimeter radius. Okay, and how do I know? First of all, I make the equation, I make the function. The function here is given to me. I have R0, I substitute, I just simplify it. And then from here is just a mathematical function based on one variable, done. You can find the first derivative equals 0, find the answer for R, find the answer for R, and then find second derivative, sub the answer and see if it's negative and say yes, 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 this is maximum. And then you have the answer. So S, which is the speed, is maximum at 1 centimeter. The percentage of codling moth that survive the pupa stage at a given temperature is modeled by this formula. So here I just say this is the temperature and this is my function. Find the temperature at which the greatest percentage survives. Okay. So here I'm just finding the maximum speed. So maximum of this guy. So I want to know what is this if PT is maximum. This is the whole question. Okay. So I find P prime T, which is minus 2.84 T plus 68, this, done. Okay. So then I do P prime T equals 0, and then it is minus 2.84 T plus 68 equals 0, and then T is 68. Yes, T is 68 divided by 2.84. So what's the answer? Okay, so let me make sure if I'm doing it right. Okay, so it is 2.84 T equals 68, and T is 68 divided by 2.84. Yes, 2.84. So I do 68 divided by 2.84, which is so it is 23.94. Okay, I can multiply, so I can underline that, check that it is almost yes, I can 3 significant digits, so 23.9 watts, so just Celsius. Okay, so how about second derivative? When I do second derivative, I see it is that second derivative is always negative, so yes, P is maximum at this guy. Yes, so and I found the temperature, so I can say the temperature which uh, which I have the greatest percentage of this is 23.9 Celsius. Okay, another question. The energy expended by a certain species of parakeet is given by this. So I have another function. Okay, I have v as the bird's velocity, that's kilometer per hour. What velocity minimize the energy? So I'm looking for the velocity which minimize this energy. So here I want to minimize. So doesn't matter. The procedure is the same. So first I find EV, I make it easier. I time it. Okay, so it's 1 over V 0.074 times V squared plus 35 squared, which is 1225 minus 70 V plus 22, right? Let me see. V squared plus that minus that, good. Then I say it is 0.074 V. When I multiple this with each plus this number. Okay, so this number 1225 times 0.074. Okay, 90 and 90 point, let me make sure, 0.4774, 0.074 and times 1225. Yes, 96.5. So it's 90.65. When I multiple, so I multiply this with v minus 1 because it's over v. Okay, so I can just write over v minus 70 times 0.074, which is 5.18. For the next one, it's 5.18. So I multiply 5.18, and I do plus 22 over v. So I can simplify it. 0.074 v plus 90.65 v minus 1 minus 5.18 plus 22 this. And I can make it simplify, so 22 plus 90.65, which is 112. So it is 0.074 V minus 5.18 and plus 112.65 V power minus 1. Okay, so I can make sure that I'm doing it correctly. See, it's V squared, yes, plus this, which is a squared minus 2 times that, yes, and then 22, and then this, and then this, and then I multiply them. This and this v cancel, yes, this and this, it's 1125 1225 times 0.074 is 90.65. I multiply, then I do this, and this and this cancel, so 70 times 0.074 is 5.18. So unfortunately I don't have the note in front of me. So this and this, when I multiply, yes, and then 22 over v, and then I can simplify it. Okay, so this is my function. So from the beginning to until now, I am just finding the function. I'm just making simplify. I'm just making simplify. Okay, so I'm simplifying this guy to this guy. Okay, and then from here it says what velocity minimize. So I find the first derivative. What is first derivative? So 0.074 minus 112.65 v power minus 2. Okay, and you don't need to put v prime because you do based on v. Here it's like based on x, that I don't have x prime. X prime is 1. Here I do based on v, so I don't have v prime. As you notice, for none of them I have prime. Okay, because I do based on that variable. Okay, so this is the derivative, and then I put it equal 0. Okay, I can find the answer. So it is 1, so it's 112.65 v, so v squared equal the other side 0.074, so v squared is 112.765 divided by that. Okay, so I have 112.65, oh my god, 112.65 divided by 0.074. Okay, so 1522, and then I do this guy. Yes, 39 point. Okay, it's 39.01. Okay, 39.01 is v. Okay, so I find v, so I use radical, the velocity. Okay, so the velocity is this one. And then what is e double prime? E double prime is yes, it is minus 2 times that. So so 112.65 times 2, yes, and minus 2, so it will be minus positive, so it's 225, it's 225.3, so so its double prime is minus, so I can do it step by step, this times minus 2v power minus 3. Okay, and this is 225.3, so it's 225.3 divided by this, and when I check, when I sub in the point, I can see double prime at this point. Okay, at this point is positive, for sure I have minimum. Okay, so at this speed, the yes, at this speed, and the speed of a species cannot be, let me see if it's negative. I think it doesn't matter because it just shows the direction. Okay, so the speed which makes this energy minimum, see, I checked. So here I have the equation, I have the function, and I want to see which speed means which v, this is v here, which v makes e minimum. Okay, so I just simplify the function, and then I find the first derivative, and then equals 0, and then I find v. Okay, so then I substitute in second derivative, and see second derivative is positive, so for sure I have minimum. Okay, look at that. If I put plus minus for the speed, okay, then when I substitute negative, I don't have when I substitute negative here, for example, I don't have I don't have positive second derivative, and I don't have minimum. Okay, that's why I just include positive one. Okay, so 39.01. Okay, and I see at this speed the energy is minimum, so I have to explain at this speed the energy is minimum. Here the last question, for a dosage of x centimeter cube of a certain drug, the resulting blood pressure is this. Okay, so this is centimeter cube. This is, I think it's volume of the certain drug. Okay, this is a relationship between volume of certain drug and the blood pressure. Okay, so I want maximum blood pressure. I want to see where maximum blood pressure happens, at which volume. Okay, so I doesn't matter maximum or minimum. First I have to find the first derivative, and good news, I have just based on x. This is perfect. So I find the first derivative, which is 2 times 0.05 x minus 3 times 0. This x squared, which is 0.1 x minus 0.9 x squared. And then I put equal 0, and then I have x times this times 1 minus 9 x equals 0, right? Okay, so x equals 0, which is not acceptable, and x equal 1 over 9 centimeter cube. Okay, so I can do 1 divided by 9, which is this. So I can say it is 0.111. So I underline, check that it is almost 0.11, two significant digit. Okay, centimeter cube. Okay, how do I know this is maximum? So I can find the second derivative. When I find the second derivative, I can see it is this minus 1.8x, and I can see second derivative at this point is negative. So for sure I have maximum. Okay, this is the test of second derivative. Okay, so I have maximum. So the blood pressure is maximum at this, so at this dosage of x. Okay, so these are easy questions, because you have a function, the function is given to you, you don't need to find it, the function is in the question. Also, you don't have two variables, you just have one variable, so you just do the first derivative equals 0, find second derivative and check at that point is maximum or minimum. Yes, it is, and then it's done. You just have the answer. But if you have to make the equation, like here, you have to make the equation, for example, like here, if you have two variables, if you have to remove one of them, so you have to do more work, but the process is all the same. Okay, so hopefully this is helpful. So next I go to, so we are done by derivative and application. Now I go to the antiderivative and integral, and then we are done. Thank you so much. Bye.